From across the globe, from the center of aerospace. And now to you.
Thank you for downloading the Aero Society podcast from the Royal Aeronautical Society.
Welcome to another night at Waterside. I'd like to welcome Faizan Pantankar, who's come to talk to us today about AI in aerospace, I guess in the engine business. Faizan, it says here, is a chap who's entrepreneurial. He's currently working as the head of venturing and incubation activities at Rolls-Royce. You better explain that one to us, because we oldies perhaps would call it something else, like new business or things like that. Technology manager, call it what you will. Please tell us. I'm not going to say anything else tonight. I'm going to hand straight over to Faizan. Faizan, welcome to our organisation, the Heathrow branch. I'm looking forward to hearing from you.
Excellent. Thank you so much. And I'm glad you didn't read through the whole thing, because so you see, you have to give an author bio or the speaker bio, and that's like, okay, wow, you know, we make things, we do things. That's pretty much it. As in any corporate, you have titles to go at it. So venturing and incubation lead, what does that mean? So this is something I will cover a little bit more as we go through the presentation. But essentially, it means how do we work with ideas? How do we incubate those ideas in the digital world? How do we get a large organization like Rolls-Royce, who has customers everywhere in the world? How do we co-create solutions together, and why co-creation is important? And all these things will be discussed as we go through the presentation. Well, one of the things I do want to mention is, you could say how to wow your customers using big data, how to wow your customers using IoT. The latest trend is how to wow your customers using blockchain in aerospace. So you can substitute the technology name for anything. What matters is your customers, okay? Technology, it's just a tool, okay? AI, artificial intelligence, that I'm going to keep calling AI from now on, AI is not going to solve problems on its own. AI is not the magical answer. It's a tool. It's what you do with it. So think about music, okay? Today, when people speak about music, most of the news is, hey, how do I get music on my phone? How do you use, well, not how do you use, but how many songs do you have on your iPod? Or how much do you listen to on Spotify? These are music streaming technologies. Well, let's just forget the technology. Let's go back. As long as civilization has existed, we've listened to music. I don't think the music has gotten any better over the last 100 years. What has changed is the way that music is delivered to the end customer. So previously, we would listen to music as groups in villages. Then over the next 100 years or so, music came into homes, as these music players. I don't even know what we call them, because it was at a time when we just said, oh, this is a music player. They would be so huge with big speakers, and they would play music. Then came the Walkman. And what Walkman did for the first time is allowed you to take your music with you. It didn't make music any better. It changed the experience for the customer. It let you take that music with you everywhere you went. Then came Apple, and Apple said, hey, we are going to create iPods. And so, after iPods, we have streaming services. My point being, technologies are just that. I think what's happening is, previously, technologies would be known as, oh, there was something physical. A Walkman was something physical you could show off, saying, hey, this is new technology, even though you wouldn't call it technology because that was a product. Ultimately, that was new technology. In this digital world, things are more intangible. You can't see AI, you can't see IoT or big data. These are technologies that are enablers to solving customer problems. So to wow your customer, please don't walk away from this talk going, yeah, AI is the way to wow your customer. Okay? It isn't. AI is one way to wow your customers. There's a whole process around it. I've been fortunate enough to work in Rolls-Royce, where, over the last 7 years, we've gone on this journey related to the engine business, yes, but we've gone on this journey of using data, and maturing our concepts to say, ultimately, this is how AI is working in aerospace. Along the way, we've learned how human factors comes into picture, what it takes to wow your customers. And when I signed up for this talk, I didn't know we would be in, auditorium, which is at British Airways. Otherwise, that wow would be in, a bit smaller than it was, because, yes, to wow your customers, standing in front of your customers at your customer premises, it's a bit bold. But I think let's just say that technology is just it's a tool. Let's not walk away with saying AI is going to, solve all the problems. It's a tool which should be used along with other things. So now that that's cleared up, I think I'll speak a little bit about what R² Data Labs is. I don't know how many of you know R² Data Labs. So that's the part of Rolls-Royce, which is all about data innovation. What do I mean by data innovation? Well, we all agree that there's way more data being captured by a lot of our devices. Well, whether that's your personal devices, your watch, your phone, your heating at home, your TV at home, doesn't matter. All the way to more heavy assets like engines, aircrafts, and all the support ecosystem around these assets. So we try and extract value from these. And I'll go into a little bit of detail on what we do that. However, it's important to realize that Rolls-Royce has 3 mega threads in the business at the moment. One is the drive for cleaner power. The second mega thread is electrification, the fusion of mechanical and electrical technologies. And I'm hoping over the next few months, latter half of this year, you'll start hearing more from Rolls-Royce on the aspects of electrification. It's an exciting challenge. The third mega thread, which is a mega thread for a lot of organizations, or it should be a mega thread for a lot of organizations in aerospace, is digitalization. It's the fusion of mechanical and digital technologies. It's important. It's easy for us to say this is what we are doing, but it's also our duty to help the aerospace industry to understand digitalization is important for aerospace industry. And I'll tell you why. So within the digitalization aspect for Rolls-Royce, there are 3 key elements. The first is perfecting the digital twin. How many of you, by show of hands, understand what a digital twin is? Okay, three or 4, so I'm asking so I can just speak a little bit about it. Digital twin is, in the simplest manner, it's a virtual product. What it does is it twins the physical product in a virtual world where you can add simulations, you can make the changes, and it behaves exactly in the same manner as the physical product would. Now imagine the test that the engines go through to create a virtual product that would replicate those tests in detail with enough confidence to be used for pass-off. Yeah, that's incredibly powerful. To suddenly trust a machine to run a simulation and say, you know what, this is the test. There is no physical test of the engine anymore. So that is a digital twin. That is the virtual replica of the physical product. And a lot of organizations are focusing on creating digital twins. Where Rolls-Royce goes ahead is we are not just creating a twin of the product. So we are not just creating a virtual engine. We are also virtualizing how our production services are operating. We then also virtualize how the service, the aftermarket service is being delivered. And what does that do? It gives you, a completely data-driven organization. Suddenly you have Rolls-Royce in the real world and Rolls-Royce in the virtual world, where you can make a change and see in the virtual world what that change is going to do to the organization. So this is perfecting the digital twin is one of the key threads within digitalization for Rolls-Royce. The second one, which is what R² Data Labs, the place I work at, is at the forefront of, is around amplifying and accelerating data innovation. It's how do you take the data that you're receiving, and turn that into value. Whether it's big data, artificial intelligence, even blockchain, and quantum in the future, they all require good data, good structured data. So it's the use of that data and using it in a manner that solves our customers' problems that's important. And we are at the forefront of it. To do all of this, to create a digital twin, to actually do data innovation, we need to be a digital-first business. And that's important. What do we mean by digital-first business? It doesn't just mean I now have the ability to do e-signatures. That's not being digital. You have to look at all the processes that were created and how do you disrupt them? How do you cannibalize some of the things which we've been doing because it's been done for 15, 20 years? To make a change for that, you need a change in your mindset. We have about 46,000 employees. They're all geared up to do manufacturing. How do you retrain the employees? How do you retrain the workforce to be digital first? We can't just say, well, we are going to use more digital technology, so we have to replace 46,000 employees. That's not possible. That is a question that aerospace has to answer as well. How do you create a digital-first culture? How do you change the mindset? How do you start trusting machines to complement what the human knowledge was or is? So these three things, you could honestly take this in any aerospace business, and in my opinion, they're equally important. And the reason we share this openly with anyone and everyone from a Rolls-Royce perspective is because we want to see the industry develop and go towards accelerate their own digital journey. So this is what R² does. This is what digitalization is important for Rolls-Royce. And all of this fits into the talk about artificial intelligence, because you can't do artificial intelligence projects in a silo. You have to be at scale. I think gone are the days when large corporates could do things in silo and say, we are doing something with AI. Well, if it isn't cannibalizing something we were doing before, why are we doing it? If it's not replacing our old methods and processes, why are we doing it? And that's the journey I was on, which I'll share. So, the question is, how do you wow your customers? Faizan, that's what we are here to know. And before I give you the answer of how to wow your customers, there are two things that are important. The first is know who your customers are. And the second thing is understand your customers. It's easy for me to stand here and answer my customers are, British Airways are customers. I can solve their problems using AI. The first part of that answer is right. British Airways are customers. I cannot solve their problem until I understand their behavior, until I understand what is it that I want to solve, or what are their pain points. So when you embark on using artificial intelligence, and you'll hear this from a lot of consultants, I've got nothing against consultants, except the fact that, right now they're going everywhere in the industry saying AI, IoT, big data is going to solve your problems. How? Show me a large-scale project you've done that has impacted the industry. The answer to that is, well, yeah, we've done some projects. We've done some proof of concepts. Well, you have to understand the pain point of your customers to then go and solve those pain points. This chart over here just shows the number of years it took to get to 50 million users. In this case, I'm going to liberally term users as customers. Okay? It took airlines 68 years, and don't follow all the numbers, trust me. You know, I'll speak out the 4 that really matter. But airlines, it took 68 years for airlines to reach 50 million customers. Facebook took 3 years to reach 50 million customers. Twitter took 2 years to reach 50 million customers. And Pokemon Go, it took them 19 days. For those of you who don't know what Pokemon Go is, it's a virtual reality game. It's a mobile game. It's a game that literally just helped me walk a little bit more for 10 days. You know, and that got 50 million customers. Now you think, well, why does that matter to us? You know, why does Facebook, Twitter, Pokemon Go, YouTube, iPods, why do these things matter to us? And I would love to say they don't. But the truth is, they matter. They matter on the digital journey that we go on. Because suddenly, our customers, and the view of customers is weird, right? Because everybody thinks, oh, your customer is either a safety manager, or your customer is an engineering director, or your customer is a fuel manager who are sitting on nice, pristine desks, you know, and signing off on things. It doesn't matter that way. Everybody today has a mobile device in their hand. They're using Facebook to post pics, to get updates. Twitter, I don't know how many of you use Twitter or even know Twitter, but people expect their support questions to be answered on Twitter. British Airways has a Twitter account which helps people with support, as do all other airlines. The point being, this is the new method of communication. Pokemon Go, why does that matter? People suddenly experienced what virtual reality is like. And it matters because their behavior is now influenced by these things. So when you start using AI, you need to think about how are people being influenced. And people are being influenced by these technologies. So we can't, at Rolls-Royce or anywhere else, genuinely sit on our desks and say, we understand our customers because we met them 10 years ago. Well, that doesn't work. Your customers are changing. The graduates of today are the managers of tomorrow and the customers of day after. The graduates who are, you know, or the young people today who are using these things are one day going to run airlines. They are going to run other companies. That's the experience they want. So imagine when we supply them with laptops and say, log on to this website and use a technology that was developed in 1995. It doesn't cut. We are noticing that now. Okay, it doesn't cut. People need the latest technology, and they want to use it in a seamless manner. Gone are the days where work would be 9 to 5. For some of us, it was never 9 to 5. But people expect to be working, you know, they want to check their email at 7. They want to log on to the phones, look at the trends developing in that engine, reply to someone over the phone, and get the issue closed out. They don't want to fill in papers. They don't want to walk around even with an iPad. They want it all on their phone. So it's important when we speak about using AI or any other technique that to wow your customer, you need to understand your customer. Now, the one thing I will speak about this plot is, yes, it took airlines 68 years to reach 50 million customers, okay? Pokemon Go can shut down tomorrow, and it's not going to affect the world. Airlines can't shut down tomorrow. So some things take time, okay, and we have to appreciate that as well. So, going through all of that, which really doesn't mean a lot in the aerospace industry, but it means a lot if you want to wow your customer, because it helps you understand the behaviors of your customer. The way these Facebook or Twitter operate their business is the way Rolls-Royce wants to operate the business. We want to start creating, and we are already creating products and services that use tools, techniques, methods, mindset that Facebook, Twitter, Google, and Amazon uses. Of course, the pace at which that's happening, can be argued with. But the principle that we are on the same journey is something that's true and out there. So one of the examples that I'm going to use to show you what a typical AI journey looks like is the engine health monitoring service. It's what we call the EHM service. I assume a lot of people know about the EHM service. By show of hands, how many of you know the Rolls-Royce's EHM service or total care service? Okay, it's roughly 50-50. So just very briefly, and those of you who think this is wrong, please don't speak up now. EHM service is essentially a Rolls-Royce's total care service, and EHM is a part of that. What it means is, you fly your aircraft on engines from Rolls-Royce, and Rolls-Royce will take care of the maintenance. We'll replace the engine if it needs to be replaced. We'll maintain the engine through our maintenance, through our MRO shops. We'll replace the parts, etc., etc. Wow. And by the way, you don't need to pay anything more. You just pay by the hour for this. Okay, that's excellent. Why would you do that, Rolls-Royce? So the answer is because we are very confident in predicting things before they happen. Our EHM service can predict if there's a failure developing in an engine. Let me be very clear. When I speak about failures and things, it's not safety related. This is maintenance related. What does it take to wow our customers? At Rolls-Royce, it actually takes very little. Well, not very little. It's a very simple mantra. How do you wow your customers? You wow your customers by providing them disruption-free travel. We don't want airlines to be disrupted because they will then have to face the brunt of their customers. So we want our airlines to fly reliably. We want the airlines to fly disruption-free, and we want to provide them with, the best fuel efficiency and other things. So EHM is one service that I'll take you through. On the top, the first bit is a simple chart, which I don't know, most of you, and I still look at in some instances. Forget what the XCs are and what what it actually means. But this is how, until 2013, Rolls-Royce was looking at the engine data. There would be humans looking at these trends, trying to spot if there is a trend which deviates from what it should be. Rolls-Royce, as an OEM, had access to the design information. So we have the design data. We have the in-service data. We also have other information like how was it actually produced and what was the data like when it was passed off. So in the world of analytics, in the world of digital data analytics, what generally happens is, and a lot of organizations even today do this, they will look at that data and see if there was a trend on the green, on the top, if there was a change in the top trend. Imagine a spike. A spike would tell the human something has gone wrong. And then the humans would have, and I say this, it sounds very sinister. I don't mean this in a sinister manner when I say the humans, but I mean my colleagues and my team. We would look at it and go, there is something wrong happening with this engine. And this was until 2013, which is okay because you had, the older families of engines which had less data coming through. But do you know that how many engines are flying? I mean, at any time, we are looking at 7,000 engines in the air. Imagine the operation that happens behind the scenes to constantly look at that data. And then to deduce what's happening with the temperature, what's happening with the pressure, where the vibrations, and other parameters to conclude if something wrong is happening with the engine. That, by the way, in 2013 was state of the art. I speak to a lot of startups today trying to understand what they're doing and how we could help them. And most of them are still doing that. That was 2013 for us. In 2014, me and my team, we set off to say, how do we try the machine to do this work for us without human intervention? And so we began implementing, we created a patented technology called diagnostic networks. They're similar to neural networks, and I won't go into the details of neural networks. That can be quite boring. But what it is imagine going to a doctor. I come from India, so it's probably GP for you here. We just say doctor. Turning up to the doctor, and the doctor would ask, would check, are you running high temperature? Are you coughing? Etc., etc., to then tell you, okay, this is what's wrong, and here's the medication for it. Diagnostic networks, the second method, would do something similar. It would look at multiple trends to then make a conclusion that this is the possible failure that's happening with the engine. So, and this would happen before time. The beauty of this is it would happen well in advance of the impending failure. So that would allow Rolls-Royce to either ship an engine from Derby to anywhere else in the world or carry out maintenance. The point being that the aircraft shouldn't be on the ground. There shouldn't be disruption. Because you don't want your customers with the airline logo posting on Facebook and Twitter that their holiday is ruined. Believe it or not, speaking to CEOs is fine. When something comes up in the news, we first check what engine it is because we would get hammered on Twitter and Facebook. So that is the second aspect. That's where we started using a machine to start doing things instead of humans. And that was in 2014 where we began implementing that project with my team. And we were quite proud of ourselves that suddenly a machine could do this without humans being necessary. But you know what we did? We essentially took all the human knowledge we had gathered in 2013, up to 2013, and we programmed it. We just said, if this happens, do this, etc., etc. How do we know that by 2013, all the decisions we had taken were the right decisions? How do we know that what we did in 2014 is actually just do everything we did up to 2013? Now, instead of a human, a machine did that. Did we add any more intelligence to it? And the answer is, in reflection, I think we didn't add any more intelligence to it. We just made it more scalable. And what I mean by more scalable is that the engine or the machine could look at more data. I'm not saying it made better decisions, it just looked at more. So with that nagging us, in 2016, me and my team started looking at how do we get humans completely out of the loop? What system can we create where an engine, which is flying, sends us data, we look at that data, and when I say we, a machine looks at that data, and without any human intervention, the machine sends out the message saying there is something possibly going wrong with this engine. You need to carry out these actions. The answer was, well, yeah, go look at it, because we don't think that's possible. Because Rolls-Royce understands aerospace better than anybody else. No machine can outdo this. So that's where we started looking at artificial intelligence techniques. That's where we started looking at machine learning techniques. Now, one of the things we realized is The work we had done in 2014, the reason why it did not improve on what had happened until 2013, it had improved, but not enough for people like me to be, happy about it. Okay? AI should bring you a huge benefit. Anybody who thinks, AI will only bring you 5-10% benefit, that project doesn't need AI and it's not worth doing. So, I don't know how many of you know, but a human brain can only make an efficient decision by taking into account 4 variables. So I could be looking at 4 trends to say, okay, this is what's probably going wrong. That's what a human brain can do. In some instances, a human brain can look at 5 variables. So you can look at 5 options to make a good decision. You need a very high IQ to do that. Most humans are not capable of it. Superhuman beings, apparently there are a few of these in the world, who could look at up to 6 different data points or 6 different variables to make a decision. It's almost like saying, I'm going to look out of that door, also from the corner of my eye, look at this plot, see what's going on in the AV room upstairs, look at that table, see here, and conclude what's actually going to happen. It's not possible. A human brain can't do that. I can only look at this and conclude that, I'm probably going to go to the next slide or what I'm seeing over here. AI, in 2016, we started implementing with my team a technique that could look at over 20 plus variables. So it didn't just look at what we knew, it started looking at things we didn't know as well. And this is where artificial intelligence becomes very important. It's also why artificial intelligence can be or is considered a bit of a risk at the moment. Because the artificial intelligence started coming up with answers that we couldn't give. So suddenly, imagine a world where a machine tells you, I think this is what's happening with the engine. Something's possibly going wrong. And we would have the best domain experts looking at all the data, saying, the machine is telling us something's going wrong with this, and the experts couldn't work it out. Why? All our logic rules are there. We haven't taken them out, and none of them are telling us something's going wrong. What we realized then is that the artificial intelligence is now moving away from the known territory. Now, this is another complex topic, so forgive me. But in the world of statistics, there are known knowns, so you know how a failure is going to happen. I'm trivializing things over here. You also know that you don't know something. This began with something to do with the war, by the way. So imagine bringing something that happened in the war back to the world of data. But in 2016, we started realizing that the machine was telling us about things we did not even know could happen. And suddenly, we saw a huge uplift in what our EHM service could do. Because, it doesn't matter if people speak about AI. Do you know how people predict things? People simply predict things by learning how those things happened in the past. It's almost like, it's like kids. The way kids learn something is by constantly learning either from their parents or their surrounding, picking up on those words and saying things. In a way, artificial intelligence in its simplest form is that it learns what has happened before, and it learns to spot that if it's happening again. But what if it has never ever happened before? What if there is a particular failure in an engine which we have never ever seen, but is now happening? There are no rules for that. It wasn't designed. The engine did not have that failure designed. When we tested the engine, that failure wasn't there. So there is nothing to learn from. And that's where AI comes in, where it goes, actually, I know there is something happening here that you don't know about. And we had to go through a huge program to understand whether this is true or false. I'll just share one example. When we started telling our engineers that there is something wrong with the engine, we would often be met with, "You're wrong." It's like, okay, I'm wrong, fine. Why do you think I'm wrong? And the answer would be, well, don't ask me. You tell me why you're right. And this is an interesting question. The thing about AI is the artificial intelligence cannot explain itself. It's a black box. And I don't mean, actually, yeah, that's a bad term because there are black boxes in aircrafts, but which actually give you the answers. In the world of artificial intelligence, this black box, it doesn't tell you how it has come to an answer. So those of you who are in committees and groups who help with regulations and certifications, imagine if somebody came to you and said, "I have an answer, but I don't know how it arrived at this answer. I can't explain why this has happened." Yeah, that's a very tricky topic. It's a topic that's tricky not from a technical perspective, but how do you get humans to believe something when you can't explain how they've arrived at that decision? And we might think this is just because it's in aerospace. No, this isn't just because it's in aerospace. Yeah, companies like Google, they've had to shut down experiments. And they've shut down experiments because they had taught two different, should I call them robots or should I call them algorithms? Let's just say machines. They had taught two different machines to do tasks and speak in a particular language. Over a period of time, those two machines created their own new language. A human had not programmed them. And humans couldn't understand what is this new language that the machines are speaking. And they had to shut down the program because this isn't what the AI was intended to do. So we are in this world where the AI is telling us something, we understand that it's right, but we can't explain it. And that's a subject which, imagine even at an engine level, getting people to trust that was a huge program. And the only way we could solve it is by actually working with our engineers. And I think now that I've mentioned engineers, it's worth pointing out, these are just a couple of things that speak about, why the stuff I was saying that where you don't need a fault to have occurred. The AI could learn in real life. So you can start predicting things which we've never ever seen before. So nobody, and I say nobody in Rolls-Royce has any knowledge that this failure is going to happen. So in a way, the world of Rolls-Royce has never ever seen this failure. But the machine told us that there is a failure happening. And so the program is ongoing. But it also, if you see the last point over there, it replaces 75% of visual anomaly detection. Suddenly, we weren't looking at this data from there were no human eyes anymore on this. I mean, that's huge for an organization that only a couple of years ago was looking at 7,000 flights in the air every day. We were now suddenly down to just looking at 25% of those. Because we trusted the AI so much and we put it through so much rigor that 75% of the work that was everyday work for us was now being done by a machine. These also have huge consequences to what it means for the workforce. And that's not a topic that I'll go into today. But when we speak about using AI, I think people need to also reflect on what it could mean for the workforce, what it also means to get people's trust in believing what the AI is telling you. So, on the point of engineering, I'm a mechanical engineer, okay? People often confuse me with a software person or somebody who's done programming. No, I haven't done that at all. And I was speaking to somebody in Rolls-Royce earlier, and I think they said something which stuck with me for a while. Musicians, they don't make violins. They make music. We are engineers. Well, those of us who are engineers, we are engineers. The job of software and programming folks is to create the tools that we use to build our solutions. So when people speak about using AI, AI is offered by companies like Microsoft. When I say AI tools. AI tools are offered by companies like Amazon. They're offered by Google and many other software vendors. And I think we lose the essence when the topic of AI comes in and people go, yeah, but we are engineers. Well, absolutely. So why is suddenly AI any different to a computer? Why is AI any different to even some basic things like a calculator? Why is AI thought of in a different term to some of the engineering languages like MATLAB or any other? AI is a tool. If we as engineers don't make the right use of it, then I don't think AI is going to benefit aerospace. In all of the projects that I mentioned from 2013 until 2016, it's the start of 2017 when I left the whole project eventually, we didn't have one single software developer on that team. It was mostly mechanical engineers like myself, loads of aerospace engineers, of course, service engineers who had been, technicians who had been in this job for 20, 30 years. So it's easy to think of AI in the terms of, oh, that's programming. No, it isn't. We are the musicians in the aerospace industry. The tools are there. We need to start using those tools, to help the industry. So I genuinely hope this is something that's looked at. And I don't know from a society perspective, from this society's perspective, I can speak from IMechE, less from RES. But how many times or what CPD actions are there for digital, for data, for artificial intelligence? What do we do as the industry moves towards starting to use AI for aerospace? It isn't the end of engineers as such. If anything, we need to start using these tools faster than anybody else because we understand the problem domain. The machine doesn't understand that it's keeping an engine in the air. It's us as engineers who understand that we're using this on engines. So this is the rigor that it should meet. So when we speak to Microsoft, they're often surprised. Why would you do that? And it's like, well, that's our job. That's what we do. So, when people, I don't know, but I often see this in the news. Most of these software vendors have use cases where they boast about how you can, they're managing retail, where somebody can make a call, an inventory log has been made, an item has been shipped, and it only takes 2 days, and it saves company so much. In the business that we are in, if British Airways was to pick up the call and say, I need this engine, we are late already. Because our job is to offer a disruption-free service. So whilst these software vendors are using AI to simplify all the tasks which don't need AI, they're surprised that for us, we're pushing the boundaries of what it means to use AI tools. And when I say us, I don't really mean Rolls-Royce. I genuinely mean from an aerospace perspective, because we work in a highly regulated environment. These tools were never built with that mindset. So to push them, of course it helps them, but they don't really know what to do. It's the engineers in our companies that help them and help ourselves to use those tools and take the industry in a direction that matters. Over the next couple of slides, it's really examples of saying, because all the other images that you've seen, those images were ugly. I'm going to say it myself. Okay, those images were essentially trends. Imagine if I gave that trend to somebody at an airline saying, look at this, here's the knowledge you need. That's not the knowledge they need. They need a product. Remember why I spoke about Twitter, Facebook, and Pokemon Go? It's because they're now used to looking at products, either on their phones or on their iPads. Nobody wants to look at plots. Or I hope nobody wants to look at plots anymore. So this is one of the two products we've created, which is essentially artificial intelligence across the whole fleet. So it's not just telling you what's happening, it looks at the whole fleet and goes, this is what's happening with the whole family of engines. We do something similar for flight planning that uses AI on fuel analysis. There's lots of companies that do fuel analysis, and those who can do it well, they can do it really well. But you see now the theme emerges that, okay, there's AI for fuel, there's AI for engines, there's AI for aircraft. What does this really mean? Well, at Rolls-Royce, because we've gone on this journey and we've said, okay, we've got AI for fuel, which is working really well and saving airlines fuel and managing the flights better. We have artificial intelligence applied on our EHM service. And we have engines which are giving us more data than ever before. So we thought, what if all these things were connected? What if an engine in air could make its own decision that, hey, somebody needs to do a health checkup on me because I feel this is going wrong? What if it understands from the AI on fuel that why am I consuming more fuel than I've consumed before? And even better, what if one particular engine is comparing itself to all the engines in the same family? So what if one engine on an aircraft is going, why am I using more fuel on this route whilst all the engines, other engines, have used less fuel? And let the engine decide for itself. Let the AI help the engine to make those decisions and make those engines connected, not just to Rolls-Royce. Why should an engine tell Rolls-Royce something is happening for then Rolls-Royce to pick up the phone to our airline customers and say, hey, we think something is happening, we need to do a change? What if the engine could tell both Rolls-Royce and the airline and put a log in the MRO facility that, I'm possibly going to come in the next 14 days. This is what's going to happen. Rolls-Royce has already got a notification that they have to send an engine or parts through. That is the concept of intelligent engine. So, yes, we did the program in 2016, which my colleagues are now implementing. But that's not where it stops. See, one of the beauties that I've realized of using artificial intelligence, and getting a taste for it is how far this can go. Suddenly, everything is connected. Now, where did we get this lesson from? Everything connected is not something that we've gone, oh, wow, this is revolutionary, this is our concept. No, the revolutionary aspect is utilizing that mindset on engines. Facebook, Google, and all the other services, they have already done this. If you are online today, you are connected in way more dimensions than you can even imagine. If you have a smartphone, a smart home speaker like Alexa or Google Home, speakers that you can speak to, you can make an order to, they can then shop for you, they can read your emails and tell you what's happening, they can read your emails and make a booking in your calendar to remind you that something's happening. The whole aspect of a connected life is already in place. Okay, we are bringing that to the aerospace industry. Now, the question here is, how far do you think intelligent engine is? It's not a physical new engine. It's an engine, it's a concept. How far do you think the aerospace industry is from accepting this concept, from accepting that the engines can talk to each other and make decisions themselves? I mean, I spoke to you about using AI on just the trends, just the data, and comparing it to what we used to do before. And my own colleagues would not trust me on that. Now imagine doing that with your customers and the regulators and the world. And the whole concept of cybersecurity then comes into picture. Now it's easy for us, or if it's easy to dismiss this concept that this will never happen. You can never talk to the engine. But I don't know how many of you know the Pearl 15, our new engine, which goes on the Bombardier fleets, so they're mostly going to be corporate jets. There's a two-way communication. And what that means is the engine sends data through satellites to Rolls-Royce, and Rolls-Royce engineers around the world can speak to that engine. And I say these terms, change the configuration of that engine, and I mean that in a sense of data. Because we all understand that it is expensive to send data through satellite from engines to Earth. So sometimes you don't capture the right data. We're now moving into this world, and that engine is going through certification, right? So this is real. Nothing I'm speaking is hypothetical or a concept that is out there. No, we're working on it. And this is happening. Yeah, the videos about this online, you can see. But for the first time ever, bidirectional comms, which is the engine sending us data, and for us, eventually it'll be AI. But right now, the human's going, I need some different data. So let me make it efficient for you, dear customer, by reconfiguring the engine over the air to send me different kind of data. So that is our way of testing how this communication goes. So the intelligent engine concepts of engines then eventually talking to each other, talking to the airline, talking to Rolls-Royce, and the ecosystem around it is something that I feel is doable. It's doable in a short period of time. Now, what the aerospace industry makes of it is something that we'll find out as we test things out. But that is the whole intelligent engine concept. Okay. So I've spoken about our AI journey, which really began with looking at trends. Then we started codifying those trends. And eventually we started getting the humans out of it and saying, hey, machine, make the decision for us. We'll review your decision until we trust you. But we started trusting them. Now you see, one of the things we deal with today is pace. Everyone wants things quickly. I used to work with someone for whom pace meant it would take 5 years, if not more. I mean, aerospace is an industry where we develop a new product, and it's a 10-year new product cycle, okay? Which is okay. Like NASA, when they talk about their missions, they talk about 20 years before the launch, and as I now read recently, you don't get the data back for at least another 10 years in some cases. So in this world where it takes 10 years to create new products, airlines are our customers. They want pace. So if we can't make those physical products any faster, we need to create digital products and services that simplify their lives. There is enough data in the world. Honestly, when I hear about discussions that, okay, how do we get more data? There is enough data. It's what we do with that data that's missing. So how do we start testing new concepts? How do we start using what we've done with AI and help the whole industry to learn from it, to start testing new concepts? So at R-Square Data Labs, we do that by using Agile method. So how many of you know or have heard about Agile? Some of you. How many of you have heard about Waterfall? The same number of people. So Waterfall method is essentially what the industry uses. The Waterfall method is what everybody in this world, apart from companies like Apple, Amazon, Facebook, Google, Twitter, Pokemon Go, and the new companies, apart from the new digital businesses, everybody uses Waterfall. And what the Waterfall method is you start a program and say, this is what we're going to achieve at the end of 5 years. And you create a huge project plan, then give it to somebody to run that project, and then you realize, a lot of this still happens in the public domain, that the project is too late, it's over budget, and by the end of 5 years, nobody probably even wants it anymore because things have changed. You see, change has always been happening in this world. What's different today is the rate of that change has accelerated. So, when people speak about things around AI is going to take people's jobs, aren't you worried about it? It's like, okay, let's not escalate things that quickly. If you think about farming, hundreds of years ago, whole villages, they would have one job, which is you go on the farm and you farm. Then came the earth-moving equipments, the tractors, and the farming machines. These are new technologies. And what did they do? You don't need as many helping workers on the farm anymore. The farmer is able to do a lot more of the activity. So technology, for as long as civilization has existed, technology has been affecting humans in a predictable manner. The difference is you now have artificial intelligence. We have blockchain coming online. We then have quantum and all the other things. It's the rate at which these technologies are coming in and people are adopting them. That is something different. So, coming back to Waterfall and Agile, at Rolls-Royce, let me be honest, I don't think this is across Rolls-Royce. Okay, this is R² Data Labs, and as part of being a digital-first business, we're still working on making things more agile. But what it means is stop creating 5-year plans. Those are necessary as a vision, fine. But if you want to deliver something to the aerospace industry, it's easy to think about 5 years, 10 years, this is what we want to do. But what about 2 months from now? Our airline customers really can't wait for 5 years for Rolls-Royce to do something. So we started using Agile method. And what Agile means is it's literally agility. It's designing something, building, and releasing value in small chunks. So imagine if we were to create a plan to say, Faizan, build me this room. I could tell you it will take me a year to do the stage, the chairs, the stairs, the AV room. Or I could start by saying, it will take me a month to build you a small stage with about 30 chairs and a small computer to help you get started. At the end of second month, I'll add a little bit more, and so forth and so on. So Agile methods are still, people say, oh, we are being digital. We have created a 2-year digital plan. And we're 2 months into it. It's like, okay, what have you done in 2 months? Well, we've created a plan. That's not truly being digital. How aerospace utilizes this concept of being agile, of releasing value in small chunks, is something that we have to figure out. All I can do is share how we've done it at R², but I don't see this anywhere else. I think the aerospace industry has seen a couple of failures where some companies have gone on the digital journey and they have failed on that digital journey because they've gone with the big bang approach. It takes someone some huge amount of years, there's no agility, and then they expect customers to come by. No. So what's important is if you want to go on your own artificial, using technologies like artificial intelligence or anything else, your teams need to look so different to what they may look today. So teams at Rolls-Royce today, when they are solving challenges, It's not just full of software programmers in one side, engineers on the other side. It's truly a mixture of subject matter experts, domain experts. It's people who know the physics of the problem statement. Mostly it's engine in our case, but it's understanding the physics of that. It's using the software programmers and tools like Amazon and all the other things, Microsoft, to say we need the power that you have to start making empirical decisions. This is a whole different topic, that could be argued at hours. Do you trust the physics of something? Or if there's enough data, do you trust the machine to forget the physics and just make empirical decisions? But it's important right now to have domain experts, subject matter experts, people who understand the physics of industry experts, but also software developers and programmers. And I think one thing that I haven't focused on the two things, but the one I'll speak about now is the customer. I think the world where you can keep the customer out of your project and just do things in a room, and then after 2 years show it to your customer doesn't work anymore. At least that's what we've realized at Rolls-Royce. It doesn't work anymore. One of the projects, when we were doing the implementation of AI in the aerospace example, I thought me and my team did an amazing job because we could predict something with the use of the machine 4 months in advance. So 4 months before it was going to happen, we could tell somebody at the airlines that this is what's going to happen, and you need to do X 4 months in advance. Eventually, time passed, and the customer called us saying, this thing went wrong. Why didn't you tell us this was going to go wrong? And I was like, I told you this was going to go wrong 4 months ago. And they're like, have you got a clue how many issues do we get every day? What's the point of telling me 4 months ago? Why didn't you tell me 40 days before it? Or why didn't you remind me 4 days before it happened? You see, this is the benefit of having customers as part of your team. They help you understand what their life looks like. So there's no point in being clever by saying we can now do things 4 months in advance if the outcome was still a failure. And that's why it's important to have the customer at the heart of everything you do. It's very difficult at Rolls-Royce because you're creating new engines at times, and it's difficult to bring customer in. But Rolls-Royce and even GE, more than 50% of the revenue comes from services. So there is a huge digital business, at least in our organization, which should be able to bring customers in, and we do bring customers in. Sometimes it annoys the customers at the start because they're like, well, I've told you, just go and do this. But they eventually come on board. So anybody who's starting a digital journey for their organization here, if the customer isn't part of that journey, I think you need to get your customer to be part of that journey pretty soon. So there's a lot happening in this space. And your teams should, to be fair, ideally look like that. That's not proprietary to Rolls-Royce. Any good team today solving a problem should have those disciplines within the team. So the next bit I'm going to share is about Microsoft is our partner of choice, by the way. So it's easy for me to put up their image. But more importantly, Satya Nadella, who's the CEO of Microsoft, he has said this: don't be know-it-all, be learn-it-all. And our CTO, Thomas Lee Warren, he is very keen on this. Because we proudly come from an organization, that does and builds such complex and amazing products, sometimes there is a feeling that we know everything. Yet at the same time, we see a lot of new companies starting up in aerospace on the digital side. I was pretty open when I said that fuel analysis and using artificial intelligence in fuel analysis is being done by a lot of small companies. So we are aware more so now than ever before, and it's a growing trend, that we don't know everything, but we're on a path to learn those things. And sometimes, to learn those things, you have to work with other organizations, both big and large and small organizations. But some of you might think, okay, how do I get started on my artificial intelligence applications, or what do I need to do? We were quite fortunate that we began a journey early on. For those who haven't started, I wouldn't suggest you start from scratch. Can anybody see anything on there? The intention was that nobody sees anything on it. That is literally a map of about 250 organizations from 2018, the top 250 organizations for big data. They also have platforms and artificial intelligence companies in it. There are some large organizations like Microsoft, Amazon, there's also IBM in there somewhere. In IoT, we also have GE Digital. So if my colleagues from Rolls-Royce see this, I'm sorry. But the point being, do you really think people need to start from scratch today? There's so much happening out there in the market. Is it really true that Rolls-Royce knows it all? No, there are organizations out there that we're learning from. So we have this strategy called the ecosystem strategy. And what that means is, where we think we are not able to solve challenges, we actively go out and try to work with startups. Now, why startups? Because startups show all the behaviors that we want to see in an organization. They're small, nimble, they have the agility, and they're some of the smartest folks I have met. Okay? They genuinely are. There's some people, or some startups, are in the world of, they are in the aerospace sector. And companies like Rolls-Royce, GE, Airbus, Boeing, we know these companies. We know them because they are solving some problems for our customers. And we want to learn from them, how are you doing it? Not because we want to necessarily do it ourselves, but let's do it together. If there is something that our data can help the customer with, then let me bring your technology to our customer and say, look, we can't do this any faster than this startup can. And we are genuinely being open about it. EHM is a very mature product. There's lots of competition in fuel, and then airlines have other challenges that we don't even speak about. But they are already seeking out partners. I know IAG runs the Hangar 51 program, which I don't know if the society interacts with, but programs and initiatives like Hangar 51, where startups come together for a 12-week period and get access to some amazing companies from the IAG family to solve those challenges. They are solving challenges. They are solving big data issues. They're using AI to simplify people's lives. People's lives sound very generic. Simplify customers in the aerospace industry. So, in a way, I shouldn't be here. We should be seeking out those startups to come and share this stage and show all the amazing things that are happening in aerospace. The point being, you really don't need to start from scratch. There's lots happening outside with small organizations, so you don't need to go into big consultants all the time. But these organizations also need companies like Rolls-Royce. They need experience. There's so much domain expertise sitting in this room. One of the things that startups come up to us and say, they generally go, we actually don't want you to pay for this work, Rolls-Royce. But what I need is your support, your knowledge. Because we have some of the smartest tech. What we don't know is how do we apply this with all the knowledge and experience that you have gained over the years. Hangar 51, the program, in a way tries to do that. So that's the partnership strategy. And the point being, please don't start from scratch. Of course, at Rolls-Royce, we are happy to talk about, Because I don't work in the sales team, I don't literally have to sell anything. But I genuinely often speak to organizations to share with them our journey. And what we've done, a lot of people will come up to you and say, this can also be done by them. A lot of consultants today talk about how to use IoT, blockchain, big data. How many of them keep 7,000 engines, 7,000 aircrafts, quite frankly, in the air using any of these technologies? None of them. So here we are. The point being, Square Data Labs, me personally, my team, Thomas, and anybody else, we are here to help the aerospace industry. We are here to talk about it. And in some instances, there are lots of people outside of Rolls-Royce, even startups that can help you on that challenge. So if you want to go on that journey, there's lots out there without chasing big names like Rolls-Royce all the time. And it's easy for us to think, nobody's really going to disrupt the market, is it? Well, is it? There's the two companies trying to do, in the nicest way possible, flying taxis without calling it flying taxis. I don't know how many Uber employees are members of the Royal Aeronautical Engineering Society. It would be fun to find that number. Because, yes, I've only used their names, fine. But there are other organizations who are also moving into this race. And yeah, this is not going to change life by 2025, 2030. But the point being, there are entrants who will enter this market, okay? On the digital side and on other technologies that we don't even know about. And this is not something new, right? There is a lesson in history. Well, not even history, like Apple did this 15 years ago. So until Nokia, in a way, 10 years ago, Nokia did nothing wrong. Nokia had an amazing phone. It did nothing wrong. It just did not change as fast as it should have. It didn't have the vision of creating the new smartphone that Apple had. And where they are there now. So, yes, we could think about, oh, there's a huge market, nothing is going to be disrupted. Well, companies that we shouldn't even care about, like a cab company, it's moving into a territory that we think, okay, interesting, we should have a look. What's happening there? So, yeah, I think I'm being very frank here when I say it's easy to think nobody's going to disrupt anything. No, it doesn't matter how highly regulated this industry is. When the wind is changing, it will genuinely change faster than most of us can think about. At Rolls-Royce, we are already thinking about electrification. We are on that journey. It isn't a concept. It isn't something we're talking about because, hey, it would be nice if we did this. No, we are doing it. There is no more debate about should we do it. We are doing it. And it's the same with the electric vertical takeoff and landing. We don't speak about it much. Okay, we are typical, I think, British organization. We are quite conservative about, boasting about things we do. But we do these things. And we have an eye on some exciting challenges. But we need the support of the industry. We need the industry to move at that pace as well. To go, yes, here's some support on what we could do. How that eventually happens, I don't know. But it's an exciting space, We are genuinely open to speak about all the other projects that are ongoing. And I'm more than happy to share, in a bit more detail on the journeys we take. Do reach out. I'm sure you all, in some shape or form, have access to employees in Rolls-Royce. It is genuinely a case of, finding somebody in the digital business. Square Data Labs is a very small organization. But in a digital world, you don't need to be a large organization. If startups can do it, Square Data Labs, can, with 250 people, manage that as well. But that's what I had to share today. I'm a big fan of Q&A, so I really wanted to go into some questions and answers. And whatever I say, it is genuinely from experience of doing it. I don't speak on a hypothetical manner that this is what we could do or should do, or here's an idea. I've been fortunate and lucky that I've been part of Rolls-Royce's journey as it's gone on from 2013 to 2017. And my colleagues are still doing that. And all of that has been done by engineers, not by software developers. I think that's the key takeaway I want this room to leave with. That AI, if we don't get our hands on it fast enough, it'll just be a technology that people still keep throwing around in aerospace without much value to the society. And with that, I'll end my talk now. Thank you.
Thank you very much for a fascinating presentation. I'm just curious, with an AI tool, if we get to the point where all parts are being replaced before they fail, how can the AI tool continue to learn if there are no actual failures that you get data from?
Yeah, and that's a very interesting question, because even without the AI tool, we would have the same problem. And this is the aspects of how things operate. In an ideal world, we would say something is going to go wrong. They would do something before it fails, leave a good note. We've tested this part. Yes, this was going to fail, and then let you know. None of that happens. The good news never comes back to you. The bad news, you're hammered with it. It's generally how it works. So with regards to AI, I think ultimately the way things will work is, in the world of life-limited parts, I think the ultimate decision would be, should we let this part run its life because we trust the model to have made the decision that there is nothing else that can happen with this part. If you want to provide a disruption-free service, we have to pick up the risk that some parts will come off even with some life left in it. Now, the good thing about AI, and one of the techniques we've implemented, is it doesn't need any historical information. It learns from, essentially, it looks in 20 different dimensions to go if something is changing. We are a company which has been proud about running a Project Zero campaign where we want 0 defects in anything. And ultimately, what was the aim of doing this analysis is, yes, to say, to have a disruption-free service, but also to give that feedback to the design team, saying, please design this failure out of the engine. So ultimately, if we do our job right, there shouldn't be any failures. There shouldn't be any known failures in that engine. So for me, I think we absolutely want to move in a direction where we start seeing first-of-kind failures and to remove them as soon as possible. And the techniques are out there, because, I think at least up to 3 years ago, data scientists and engineers at Rolls-Royce, we would feel, we were quite enthusiastic about finding failures because it would help train our models. Before it started hitting us that, wow, we are essentially being happy about something that went wrong with our engines. That's not a good news at all. So to answer your question in short, I think, so there are techniques. We've already implemented some which say, even without a failure being there, tell me in advance. What we need to get better at is closing out the loop of saying, should we test this part? They said, this is how much life is remaining. And yes, it was true that there was going to be a failure, but we could do some maintenance. If we do it in a digital manner where it's so seamless that somebody doesn't have to fill in forms, I think there'll be more and more of this information coming out. But ultimately, all these faults are meant to be designed out. So we should be getting more and more of, we've never seen this before, instead of, oh gosh, yeah, we've seen another one of this. How? The aim was to not see another one of this before. I hope that answers it. There's one question there.
Hello. Has there been any attempt by yourself or people you know to come up with artificial intelligence that has what we would call common sense? You mentioned earlier that even with all this AI, you still need engineers to make decisions, but can there be AI where you can get rid of, in long term, engineers or even pilots or drivers?
So it's a tricky, it's a tricky question, you know. So I'll conveniently skip the getting rid of engineers aspect, maybe touch on it a bit later. But I think what's important there is because AI as a field, there is a growing school of thought that AI is not explainable yet. It gives me an answer. It doesn't tell me in detail how it arrived at that answer. And that's why engineers need to get involved to just double check that it is true. Okay, because we are in a highly regulated industry. If I just deflect the question on thinking about what happens in the insurance companies, you put in all the data and a model just decides how much your insurance cost is going to be. And until you call someone up to negotiate with them, that's ultimately what you pay. So that has come about with all the knowledge that the insurance industry has gathered. I think in aerospace, at least in Rolls-Royce, there's enough information for us to make the conclusion that, you know, we don't need a human intervention in all the cases. But the reason we do it is because AI is not explainable yet. You know, if somebody was to audit us, okay, saying, okay, you said this engine was to be removed for this reason because the AI told you to do it, can you explain all the decisions up to that point? And the answer is the AI can't give those answers. So from an audit perspective, we have to check that this is happening. In the future, do I think that we will get to a stage where we don't need engineers to do that? Then, and this is purely my personal opinion, then yes, absolutely. I don't think we need engineers to do that. Frankly, I don't think we should have engineers doing this today. I mean, looking at trends and making a deduction from those trends is a repetitive task. Do highly qualified engineers need to do repetitive tasks like these? They should be machine-driven, and we should be solving other bigger challenges. So I hope in the future engineers don't have to do these things, because once you've codified and you've taught the model how to behave, then you shouldn't really have to interact with it much. You should move to the new challenge. Now, if the aerospace industry brings in some more regulations, then yeah, absolutely we can't get rid of that. But what if you can just codify the rules and regulations as well? Then yeah. Now that doesn't mean that we should not have engineers in an organization or there should be less mechanical, aerospace, or any other engineers required. No. I think there are way more challenges. There are way more exciting challenges to go after, which is what I want to go after. I don't want to look at those trends every day. So I hope that answers your question, that yes, eventually I don't want to see engineers do it every day. I don't want them to be part of that decision making, as long as we can explain what the AI has done. And explainable AI is something that the vendors like Microsoft, Amazon, and Google did not set out to do. Now they have to find those answers. How do you make that happen? Because until that happens, I don't think any regulatory organization is going to let AI rule the world if you can't explain what has happened.
Hi, question over here. You touched on life-limited parts earlier, and obviously life-limited parts are a big cost driver in engine operation and maintenance. So by the sound of it, with super intelligent engine health monitoring, there shouldn't necessarily be a need for any life-limited parts in the future because you could predict every failure. Do you see that being somewhere that we're headed towards? Is that already a reality? Do modern engines have fewer life-limited parts, or is there a regulatory requirement that all critical components have finite lives? And is it just a regulatory hurdle we have to overcome?
Interesting question. But I just want to clarify, when you said, in the future, do you see there won't be any life-limited parts? Did you mean, we just have parts without ever focusing on what the life is?
No, so in other words, everything could be on condition, couldn't it? Because if you can predict the failure of your turbine disk, you wouldn't need to give it a cycle life. You could just monitor it until it hits a certain threshold.
Yeah, so the way it happens today is we almost focus on the life of that part as one of the targets that the model has to achieve, minus, you give it the factor of safety. Will that ever go away? That's an interesting question. I don't know. I think to have that human empathy, that there is a backup in the sense that, okay, if the model was to fail, I at least know how much this part has been used up. So it'll always remain from a human emotion perspective. Although I do see that more and more we'll move into this direction. And we've done a couple of experiments where you do the condition monitoring of the part, but then you also, at the same time, do the fleet management to say maybe this part is not applicable is the wrong word, but maybe this part shouldn't be on this engine and this aircraft because it flies a particular route and there is slightly more risk of, this part failing. So if we do the fleet management right and tail optimization of the parts, then we could fix that part on a different engine. It does mean we will still have to go, okay, you're condition monitoring this against what? So there'll always be that human target objective. That won't go away. But I think you've just sparked an interesting thought, and we might just see if there's any way we could do an experiment where we just release a part with no life number against it. And it's all just condition monitoring of that part. But yeah, that would be interesting. I used to work in the energy industry before, where we do condition monitoring, and the parts wasn't the issue there, or the life of the part. It would be the temperature, the number of hours that it's run at a temperature. So there'll always be this human emotion with something to go at. But yes, we do some optimization. We want to do it in a more seamless manner, so more trustworthy. That yes, absolutely, move this part to a different engine. Can we do it without any part life on it? Not sure. I mean, I've not even thought about it until now. And I think it's something I'll check. It's exciting, but these are the kind of questions that engineers should get involved in. Saying, and what's the risk against it? Because one thing I haven't touched in all of this is we also do a lot of service integrity, i.e., if one of these models or algorithms or AI stops working, we need to know. It has happened before where we didn't have that system running at full integrity, in the sense one of the AI algorithms stopped working, and we didn't know until a human picked up something that the machine hadn't. So there's always a backup that needs to be there in some shape or form. But yeah, thanks for that question. It goes. There's another one.
Okay. Just three slight questions. First of all, I noticed the EVTOL, the air taxi. There was a project some years ago called the Mollusk Sky Car, which worked not on electric engines but conventional ones. But I think it was a project a little bit before its time, and they've been trying to perfect it, and they haven't really got that far. But with what you were proposing about AI and electric engines, I think suddenly the Mollusk Sky Car seems more interesting. Also, with regard AI, can AI predict your share price, or anybody's share price, which is quite an important thing?
Yeah, so taking the second question first, can AI predict share price? AI in financial industry has been running on for a long time. The way brokers and investment managers invest, or buy or sell shares is on the back of these. But that industry is so mature and so high that literally a lot of these firms lay down their own internet cables because even milliseconds, that's weird, even milliseconds delay in processing any of that data leads to millions of pounds lost. So yes, that does happen. One of the, we didn't run this experiment because it got a little bit of emotion against it, but what we wanted to do is see if, we could take the airline share price, the fuel that it's buying and running, against what we think it should run. So the way the fuel industry, not industry, but the way it works is, the pilot has the ultimate say on how much fuel an aircraft should carry. And we're not going into that debate, but could you link how much fuel the airline is carrying against how much the AI was suggesting you should carry on each aircraft, and see if that could be linked to any of the financial indicators of the organization, to see if you followed the AI's advice to detail, is there a link with the financial incentives? But hey, that never went through. That experiment just died at ideation stage. But yeah, in the finance industry, it happens. It happens every day. It's built on it. They don't care that much about improving the society using AI, but it does happen. Your first point was against the
Model Sky car.
Yeah, and forgive me for not knowing that exact project, but I mean, even in some Air Force, there are jets that have vertical takeoff. Okay, so there is an aspect of when companies like Uber and others, and there are others, okay, that is a grabbing company, so you just use that. There are companies who are involved in it, and so other companies have to get involved to keep an eye on it. So, vertical takeoff and landing is not new. I think what we have to look at, and where the industry will learn now, is there's no point in just having the technology of a flying car. Because do we have the infrastructure to support flying cars? We don't. And is there any point on saying we have a flying car anywhere on the road? Or should we be looking at data to see where are the hotspots of where this technology could actually be used? And rather than going through a mass market model, where up to now, any mode of technology, any transport mode has gone through a mass market behavior. You build a car, you just want there to be as many cars as possible. Airlines are going through a boom, at least in the Asian region. In India, it's absolutely crazy right now with the boom that's happening. So what's the point in a country like India, where the roads are busy, the trains are busy, the aircrafts are busy, to then add another layer of transport without any sense around, using data that's available to go, this is how we're going to differentiate. So when Uber comes into picture, it's not just going to release a flying car. It's part of the bigger plan of this is what the consumer's end-to-end journey looks like. And part of that journey could be driverless cars, and the other part could be used by flying cars. Flying cars is a liberal term. I'm sure by the time it will change.
And just looking in your crystal ball, do you think there would be a time where AI becomes self-aware?
AI becomes self-aware. I think, so how do you mean self-aware? Because I have something else in my mind.
It starts thinking for itself, and you decide to do something, and it turns around and says, no, you're not doing that. I'm doing what you're going to do, what I think.
Okay. So will AI become self-aware? I think the question, the thing that baffles me is, do we know if AI is self-aware right now? In the sense that, when Google, and Google is one of the companies that shut down the experiment of these two machines talking to each other, the hypothesis that I have is that the machines began speaking in a language that was not task-oriented, it was outcome-oriented. Instead of saying, no, I'm not going to use bad examples, but maybe they were self-aware that they don't need to do everything that the humans have told them to do. if it gets to a faster outcome with a different language or a shorter path. This is bizarre. This may or may not make sense to you, but if you're on this topic, it gets quite deep. I became a father about 14 months ago, and I started thinking about AI and kids in a way that my kid doesn't understand anything right now. He is aware of his surroundings. He's not learned that he shouldn't try to bang his head against the door until it starts to, ache him. But I'm going to teach him the language that I have learned. What if the language we have learned is not the most optimized language? So instead of taking 10 words to get my point across to you right now, what if I could do it in 3 words? And if I could do that in 3 words, the society would look at me and say, he doesn't have a grasp of communication. Whilst I am self-aware that I'm getting my point across to you, but nobody else can see that. Now, what if that's what we have been doing with humans? We've been teaching each other the language that we think is the most optimized. And the machines probably look at us and go, why is he thinking in that way when I can get to something faster? So the question of self-aware is, would we know that they are self-aware and they're making the right decision? I don't know.
It was the point you made about Google shut down.
Yeah.
That's
So I genuinely don't know. So.
This year in Toulouse and in London, and various airlines have had to ground their aircraft due to excessive maintenance. How could AI have helped in this area?
It's in public domain that Rolls-Royce is also in this situation right now, where there are quite a few aircraft on ground because of some particular issues with Trent 1000 engines of ours. I think one of the notions that I didn't explain when I spoke about AI can predict things is you have the known knowns, which I spoke about, you know how the engine is going to fail, and you design rules against that. You have the known unknowns. And known unknowns are, you know that the engine is going to fail, but you don't know how. So you just hold your hands up and go, there are some things that will happen which we don't know how, where AI is helping us because it can look in those dimensions and go, if I look at this particular data, I can see something. There is a third section, which is unknown unknown. So you don't even know what you don't know. You see, there is inherent, as much as AI makes up its own mind, there is a little bit of biasness because you get the AI to look at a data set that you think there is something happening, but you don't know what's happening. There is a whole different section where you don't even know that, oh, I didn't realize this data was necessary. I never thought this mattered. And AI is not even looking at it. So you see, in a way, the AI gets, as smart as it is, it gets biased by our mind by looking at something to go, okay, I'll find out what's happening here. So in some instances, in that particular instance, we have not been able to predict what has happened. We did go through a huge data gathering exercise. And I haven't mentioned data in this presentation because everyone knows data is important. How many companies in the aerospace world truly collaborate with data? Not many. So collaboration is important, okay? It's a tricky subject because how does Rolls-Royce get an airline to say, you need to collaborate with another airline to combine your data? Because the more data that there is, the better the accuracy or the output or the prediction of AI. And it's an uphill battle. It doesn't happen. And I can understand the airline's viewpoint of why it doesn't happen. But I think that's where, aircraft on grounds, like how many aircraft do you need on ground to eventually start hurting the industry to go, we need to have collaboration? because individually these problems are they're in the unknown territory. We've never seen them. So in some instances, we haven't been able to answer those questions. In other instances, we have genuinely caught first of its kind, which has never happened before. But those don't get spoken about for right reasons. But I think until collaboration comes into picture, there will always be that gap that we won't detect everything. Because those are huge questions. It's like when I tell people, it's easy to get from 0 to 60% in AI. Getting from 60 to 98% is a lot of work, but you can still do it. The final 2%, where eventually I can go, I'm absolutely satisfied, is not something we can do on us, by ourselves. That's where the data collaboration aspect comes in. But how many airlines will share the data with other airlines?
Round of applause, please.
From across the globe, from the center of aerospace. And now to you.
Thank you for downloading from the Royal Aeronautical Society. If you enjoyed this content, please consider showing your support for the Society. Share a link to this presentation by email or on your favorite social networks. If you have an interest in aerospace, consider the professional and personal benefits of membership. Visit www.aerosociety.com.